The man who discovered the smallest particle, the story of J. Thomson. In the late 19th century, the world of science was still shrouded in mystery when it came to understanding what made up matter. Chemists knew about atoms, tiny indivisible particles described by ancient philosophers and refined by scientists like Dalton, but no one had ever seen inside an atom. It was thought to be the smallest possible unit of matter, a solid, indivisible sphere. But in 1897, a quiet and brilliant British physicist named Joseph John Thomson, working at the Cavendish Laboratory in Cambridge, made a discovery that shattered that belief. He uncovered the existence of something even smaller than the atom, the electron, and forever changed the course of physics and chemistry. A young mind in love with physics. J. Thomson was born on December 18, 1856 in Manchester, England. From an early age, he showed an unusual fascination for how things worked. His curiosity about the natural world was encouraged by his family, and by the age of 14, he had already decided to pursue engineering. However, his path took an unexpected turn when he entered Trinity College, Cambridge, to study mathematics and physics. There, he developed a keen interest in electricity and magnetism, which were becoming the hottest topics in science. The mystery of cathode rays. In the late 1800s, scientists were experimenting with cathode ray tubes, sealed glass tubes with very low air pressure, fitted with electrodes at each end. When a high voltage was applied, a strange greenish glow appeared inside the tube, coming from the negative electrode, the cathode. But what were these cathode rays? Some scientists believed they were waves like light. Others argued they were tiny particles. The debate was fierce, and J. Thomson was determined to find the answer. The groundbreaking experiment, 1897. In 1897, Thomson conducted a series of ingenious experiments using an improved cathode ray tube. He passed the rays through both electric and magnetic fields, carefully measuring how much they bent. What he found was astonishing. The rays were negatively charged. They had mass but were about 1,800 times lighter than a hydrogen atom, the lightest atom known. This meant that atoms were not indivisible after all. Inside them existed tiny, negatively charged particles. Thomson had just discovered the electron, the first subatomic particle ever identified. The plum pudding model. Now that he knew atoms had smaller parts, Thomson proposed a new structure for the atom. In his plum pudding model, atoms were like a ball of positively charged pudding with negatively charged plums, electrons embedded inside. While we now know this model was not entirely correct, it was a revolutionary step forward, the first model of the atom that included subatomic particles. Impact on science. Thomson's discovery of the electron opened the door to modern atomic physics. It paved the way for Ernest Rutherford's discovery of the atomic nucleus, 1911. Niels Bohr's model of electron orbits, 1913. Quantum mechanics, which would dominate 20th century physics. In recognition of his groundbreaking work, J. Thomson was awarded the 1906 Nobel Prize in Physics. Legacy. J. Thomson was not just a discoverer of the electron, he was also an inspiring teacher. Among his students were some of the greatest physicists of the next generation, including Ernest Rutherford and Niels Bohr. He passed away in 1940, leaving behind a legacy as one of the founding fathers of modern physics. Today, every electronic device, from your smartphone to satellites, works because of the principles he uncovered. Without Thomson's electron, our world would look nothing like it does now. Fun fact. When he proposed the plum pudding model, newspapers drew cartoons of actual puddings with raisins inside to help the public understand his theory.